Welcome to CyberXplain channel. Today we are going to discuss Zero Trust, Never Trust, Always Verify. Hey everyone. Welcome back to the channel. Today, we are tackling a concept that's fundamentally changing how we think about security, Zero Trust. Forget the old castle and moat approach where we trusted everything inside the perimeter. In today's distributed world, that just doesn't cut it anymore. We've got cloud apps, remote workers, and a whole lot of interconnected devices. So, the question is, how do we protect our valuable assets when we can't even define a clear perimeter anymore? That's where Zero Trust comes in. It's a philosophical shift, really. At its heart, Zero Trust means exactly what it sounds like. We trust absolutely no one and nothing by default. Every single access request, whether it's from a user in the office, someone working from home, or even a server talking to another server, has to be rigorously verified. It's like a super strict bouncer at a club, checking everyone's ID every single time they want to come in, no matter how many times they've been before. This isn't just about passwords, it's about deeply understanding who is requesting access, what they're trying to access, and why they need it, right at that very moment. One of the absolute cornerstones of Zero Trust is the principle of least privilege. This isn't new, but Zero Trust elevates it to a whole new level. It means users, devices, and applications only get the absolute minimum access they need to perform their specific function, and nothing more. Think of it like giving a contractor only the keys to the specific rooms they need to work in, not the master key to the whole building. If an account is compromised, the damage is contained because that compromised account can't just waltz through the entire system. Next up, micro-segmentation. Imagine a large data center or a complex cloud environment. Instead of one giant, open space, Zero Trust advocates for breaking it down into tiny, secured zones. Each zone, or segment, has its own strict access controls. So, if one segment is breached, it doesn't automatically give attackers a free pass to other parts of the network. It's like having watertight compartments on a ship. If one floods, the others remain safe. This is a huge shift from traditional network segmentation, which was often much broader. This is where Zero Trust really shines: continuous monitoring. It's not enough to just verify access once. We need to constantly observe and revalidate everything. Are users still acting as expected? Is a device showing any unusual behavior? We are talking about real-time analysis of user and device posture, application access, and any changes in context. If something looks off, access can be revoked instantly. It's like having security guards constantly patrolling and checking credentials, not just at the entrance but everywhere. In a Zero Trust model, your identity systems become the primary control point. Everything revolves around confirming who you are. This means your identity and access management (IAM) solution needs to be robust, intelligent, and deeply integrated into your security infrastructure. It's no longer just about a username and password. It's about a rich set of attributes that inform access decisions. Think of it like your digital passport. It's not just your name, but also your citizenship, your travel history, and your current visa status, all contributing to whether you get across the border. You absolutely cannot have Zero Trust without multi-factor authentication, MFA. It's non-negotiable. If you are relying solely on passwords, you are already failing the Zero Trust test. MFA adds those crucial extra layers of verification: something you know, something you have, something you are. Even if an attacker steals a password, they still need that second or third factor to gain access. We are talking about integrating MFA everywhere, for every user, for every access point. No exceptions. Zero Trust isn't just about who you are, but also where you are, when you are accessing, and what device you are using. This is where contextual access comes in. An access request from a known, trusted corporate device on the internal network during normal business hours might get a different level of scrutiny than a request from an unknown device in a foreign country at 3 a.m. These dynamic, context-aware decisions significantly enhance security without overly burdening legitimate users. Ultimately, all these controls are about protecting your data. In a zero-trust world, data itself is classified and protected, regardless of where it resides. This means implementing strong encryption, both in transit and at rest. We also need granular controls over who can access specific data sets, how they can access them, and what they can do with them. It's about treating your data like precious gems, with layers of security protecting them, not just the vault they're in. Even with the best defenses, breaches can happen. But zero trust dramatically changes how you respond. Because you are constantly monitoring and have segmented your environment, you can detect a breach much faster. The limited blast radius means an incident in one area won't automatically spread. Your incident response plan needs to be tightly integrated with your IAM and monitoring tools, allowing for rapid isolation of affected systems and users. Think of it as having automated fire suppression systems in each compartment of that ship. Let's paint a picture. Imagine a popular tech company. They get hit by a sophisticated supply chain attack, a compromised third-party software update. Attackers get initial access. In a traditional model, they might have been able to move laterally within the network, exploiting trust relationships. But this company had already started adopting zero-trust principles. Even though the attackers had a foothold, every internal access attempt, every file read, every privilege escalation was met with a demand for reauthentication or a device posture check. Micro-segmentation prevented them from reaching critical intellectual property. The continuous monitoring flagged unusual activity from the compromised server. This drastically limited the attacker's ability to do damage and allowed security teams to isolate the threat much faster. So, how do we make this happen with our IAM? It's about moving beyond simple access provisioning. We need to integrate identity intelligence, think about user risk scores, device compliance status, and location data directly into our authorization policies. For instance, an identity might have access to a certain application, but if their device is flagged as non-compliant, that access is denied immediately. We are talking about dynamic, policy-driven access decisions that are continuously evaluated. Underpinning all of this is a robust policy engine. This is the brain that takes all the signals, user identity, device posture, location, time, resource sensitivity, and makes an informed decision. These engines need to be flexible, programmable, and capable of enforcing complex rules in real time. Think of it as the central command center for access control. Platforms like Entra ID, formerly Azure AD, or AWS IAM Identity Center are evolving to provide these kinds of advanced policy capabilities. We often focus on human users, but zero trust absolutely must extend to non-human identities like service accounts and APIs. These are prime targets for attackers because they often have broad, static permissions. In zero trust, these identities need to be treated with the same rigor. This means strong authentication for them, least privilege access, and continuous monitoring of their activities. Rotating credentials for service accounts, for example, becomes a critical operational task. Let's consider some attack vectors. Phishing. MFA stops it cold. Credential stuffing. MFA and continuous monitoring catch it. Pass the hash or pass the ticket attacks. Micro-segmentation and strict least privilege make lateral movement incredibly difficult. Insider threats. Continuous behavioral analysis and strict access controls limit their ability to exfiltrate data. Zero trust isn't about preventing all attacks, but about drastically reducing their success and impact. Detection is key in zero trust. We are looking for deviations from normal. This means ingesting logs from everywhere, endpoints, applications, network devices, IAM systems. We need advanced analytics, behavioral analytics, and threat intelligence to spot suspicious patterns. Think about spikes in failed login attempts to a critical system, access requests from unusual geolocations, or a service account suddenly trying to access data it's never touched before. These are the alerts that trigger deeper investigation. Where can zero trust fail? Often, it's the human element. Complex policies can be difficult to understand or manage. If policies aren't well defined, or if users constantly face friction, they'll try to bypass controls. Overprivileging is another classic failure mode. It's easier to give someone access than to figure out exactly what they need. And, of course, incomplete implementation. You can't just implement MFA and call it zero trust. It's a holistic approach. Technically, gaps can emerge too. If your monitoring isn't comprehensive, you'll miss things. If your policy engine can't integrate signals from all your security tools, it's blind in places. Legacy systems that can't support modern authentication protocols are a major headache. And if your provisioning and deprovisioning aren't automated and timely, you'll have stale access lingering around, which is a direct contradiction to zero trust principles. When we talk about identity in zero trust, protocols are fundamental. SAML, Security Assertion Markup Language, is huge for enterprise SSO, allowing you to assert an identity from one place to another, often for cloud apps. OpenID Connect, OIDC, built on OAuth 2.0, is fantastic for federated identity and consumer-facing apps. These protocols enable the secure exchange of identity information that's critical for verifying users across different systems without constantly re-authenticating. OAuth 2.0 is all about delegated authorization. It allows an application to access resources on behalf of a user without that user giving their credentials directly to the app. Think about logging into a new app with your Google account. OAuth defines specific scopes, which are essentially granular permissions that the user grants. This is perfect for zero trust because it allows for very precise control over what a third-party application can do. You grant access to just the photos, not your entire Google Drive. Kerberos, though older, is still incredibly relevant in enterprise environments, especially within Microsoft domains. It's a ticket-granting system that allows users to authenticate once and then get tickets for various network services without re-entering credentials. The beauty here is that your actual password never leaves your machine or goes over the network, significantly reducing the risk of compromise. It's a robust example of how authentication can be handled securely for internal resources. Radius and diameter are more about network access control, especially for remote connections like Wi-Fi or VPNs. Radius was an earlier standard, and diameter is its more modern, robust successor. They handle the AA, authentication, authorization, accounting, for network access. Think of them as gatekeepers for your network infrastructure, ensuring only authorized users and devices can even connect to your network segments. System for Cross-Domain Identity Management, SCIM, is a game-changer for automation. It standardizes how identity data is exchanged between different systems, especially cloud applications. This means when an employee joins, is promoted, or leaves, that change can propagate automatically to all relevant systems. This is essential for zero trust because it ensures that access rights are consistently updated, preventing orphaned accounts and ensuring least privilege is maintained dynamically. When we talk about cloud, platforms like Microsoft Entra ID and AWS IAM are where much of this zero trust magic happens. Entra ID offers conditional access policies that let you define highly granular rules based on user, device, location, and application risk. AWS IAM allows for fine-grained control over AWS resources. They're becoming the central control planes for identity and access, crucial for a zero-trust strategy in hybrid and multi-cloud environments. Migrating to the cloud doesn't automatically mean you have zero trust, but it provides powerful tools to achieve it. Cloud providers offer integrated IAM solutions, sophisticated logging, and APIs that make microsegmentation and granular access control more feasible than ever. The challenge is ensuring you are configuring these services correctly and not just lifting and shifting old, perimeter-based security models into the cloud. You need to embrace the cloud's native capabilities for identity verification and policy enforcement. So, to recap, the always verify loop in Zero Trust is continuous. It starts with an identity being strongly authenticated, ideally with MFA. Then, its access request is evaluated against dynamic policies that consider its context, device posture, location, risk score, the sensitivity of the resource. If granted, access is strictly limited by least privilege. And all of this is constantly monitored. If any signal changes negatively, access is re-evaluated or revoked. It's a dynamic, always-on verification cycle. Building a zero-trust architecture involves several key components working together. You need strong identity providers, robust policy engines, comprehensive endpoint security solutions, microsegmentation capabilities, and sophisticated security analytics. These aren't silos, they must be tightly integrated. Think of it as an ecosystem where each part contributes to the overall security posture. While network microsegmentation is crucial, Zero Trust pushes this further. We can apply similar principles at the application level, isolating different services or even functions within an application. This means a breach in one microservice doesn't automatically compromise another. This granular control is vital for protecting complex, distributed applications, especially in microservices or containerized environments. To make truly intelligent zero-trust decisions, integrating threat intelligence is vital. Knowing about emerging threats, known bad IPs, or compromised credentials allows your policy engine to make more informed and proactive decisions. For example, if a known malicious IP address is trying to access your network, the policy engine can immediately deny access, even if the user's identity seems valid. Adopting Zero Trust is a journey, not an overnight switch. It requires a phased approach, starting with the most critical assets and gradually expanding. You need executive buy-in, a clear strategy, and a commitment to continuous improvement. It's about building a more resilient security posture over time, rather than aiming for perfect security from day one. There are several technologies that are essential enablers of Zero Trust. These include identity and access management, IAM, solutions with advanced policy capabilities, security information and event management, SCIM, and security orchestration, automation, and response, SOAR, platforms for monitoring and response, endpoint detection and response, EDR, tools, and network segmentation technologies like firewalls and software-defined networking, SDN. It's important to distinguish Zero Trust from zero-day attacks. A zero-day attack exploits a vulnerability that is unknown to the vendor and for which no patch exists. Zero Trust is a security asterisk model asterisk or asterisk framework asterisk that assumes all access requests are malicious until proven otherwise. While Zero Trust can asterisk help mitigate asterisk the impact of zero-day exploits through its layered defenses and rapid detection, it's not a magic bullet against them. It's about minimizing the damage if an unknown vulnerability is exploited. Role-based access control, RBAC, is a foundational element for implementing least privilege within Zero Trust. By assigning permissions to roles rather than individual users, we simplify management and ensure consistency. In Zero Trust, RBAC is often combined with attribute-based access control, ABAC, to create even more dynamic and context-aware policies, allowing access to be granted or denied based on a wider range of conditions. A truly mature Zero Trust implementation often involves policy as code. This means defining your access control policies in a programmatic way, similar to how software is developed. This allows for version control, automated testing, and rapid deployment of policy changes. It's essential for managing the complexity of dynamic zero trust policies and ensuring they are consistently applied across your environment. It's true, a strict zero trust model can introduce some friction for users. Constant reauthentication or device checks might feel cumbersome. The key is finding the right balance. Smart implementation, leveraging context, and using technologies like SSO effectively can minimize user impact. The goal isn't to make life difficult, but to ensure that the necessary security checks are performed with as little disruption as possible for legitimate users. How do we know if our zero trust strategy is working? We need metrics. This includes things like the number of successful versus blocked access attempts based on policy, the time to detect and contain an incident, the reduction in successful lateral movement, the compliance rate of devices, and the percentage of access authenticated via MFA. Tracking these KPIs helps us understand our progress and identify areas for improvement. Zero trust isn't a static product you buy, it's an evolving strategy. As threats and technologies change, so will the implementation of zero trust. We'll see more AI and machine learning baked into policy engines, even more sophisticated device posture checks, and tighter integration across the entire security stack. The core philosophy of never trust, always verify will remain, but the tools and techniques will continue to advance. So, there you have it. Zero trust is more than just a buzzword. It's a fundamental shift in how we approach security. It's about being proactive, assuming the worst, and verifying everything. By focusing on strong identity, least privilege, micro-segmentation, and continuous monitoring, you can build a much more resilient and secure environment. Start thinking about how you can apply these principles in your own organization. Thanks for joining me today. Thanks for watching. Subscribe to the CyberXplain channel. See you on the next video.